Okay, this is our next lesson on factoring, and we add the concept of factoring the difference of two squares. That actually means factoring the difference of two perfect squares. We shorten it to just not have it be so wordy. But so whenever we say factoring the difference of two squares, we mean factoring the difference of two perfect squares. So we'll get into what that means now. Where this comes from, let's first remember the result of multiplying what we call conjugate binomials. Like x plus 7 is a binomial. X minus 7 is the same binomial except for the sign between it, between the two terms of the binomial, and that's what it means to say conjugate binomials. So 2x plus 3 and 2x minus 3 are conjugate binomials. They're not considered to be opposites. That would be if it was negative x minus 7 or negative 2x minus 3. But when the only difference is the sign between the two numbers of the two binomials being multiplied, those are called conjugate binomials. Now, we may recall from multiplying these from the last unit that when you multiply x plus 7 times x minus 7, you actually get x squared minus 49. So if you're wondering how that comes about, if we did FOIL on x plus 7 times x minus 7, we'd get x squared, and notice that the outer term is, when I multiply the outer terms, that's negative 7x. When I multiply the inners, I get positive 7x. And then I multiply the last, that's positive 7 and negative 7, I get negative 7 squared. So you notice that these two middle terms are opposite, so they equal 0. So I just get x squared minus 49. Now, the reason I'm telling you that is because when we go the other direction, factoring means what are the factors of x squared minus 49, and what we started with are factors. So the factors of the difference of two squares are conjugate binomials. Let's look at 2x plus 3 times 2x minus 3. That would be 4x squared minus 9. So if I factored 4x squared minus 9, its factors would be what I started with up here. So when you factor the difference of two squares, you get the product or multiplication of conjugate binomials. So let's see if we can put that into practice now. So if I have x squared minus 36, both of those are perfect squares. X squared is a perfect square, 36 is a perfect square, and I got the difference of them. We have now been told that that would factor to the product of conjugate binomials. Well, what times x equals x squared? X, and then remember I'm going to have a positive and a negative, doesn't matter what order those are in, and my other number is going to be the square root of 36. So what I've determined is that the factors, just like if I was factoring a number, like if I factored the number 6, that would be 2 times 3. I factored the number 15, I could say 15 times 1 or 3 times 5. I'm factoring a polynomial instead of factoring a number now. So let's look at 9x squared minus 64. 9x squared is a perfect square, so 64. I have difference of two perfect squares. And by the way, that you can't factor the sum of two perfect squares. It's considered to be prime. So if I had x squared plus 16, we consider that to be prime. You can't factor x squared plus 16 other than just like a prime number. Its factors are 1 in itself. There's no polynomials that multiply to get x squared plus 16. So, but back to this problem of 9x squared minus 64. I know that's going to be factor to the product of conjugate binomials. So the first two terms of the terms of in the conjugate binomials, the first term of each will be the square root of 9x squared, or 3x, and the second terms of the two binomials be multiplied together will be the square root of 64, which is 8. So I end up with 3x plus 8 times the quantity 3x minus 8. Again, this factors to the product of conjugate binomials. All right, so let's try just adding a little more difficulty. Notice this difference of two perfect squares has a variable in both terms. So let's think again. They are perfect squares though, so the factoring will be the product of conjugate binomials. We'll put a plus there, minus there. So x squared, its square root is x, so that goes there and there. And then the square root of 4y squared is 2y, and that's going to go there and there. So again, I have conjugate binomials that are the factors of the difference of two squares. Now if I have 9x to the fourth minus 100, remember any even power, 9's a perfect square, x to the fourth is a perfect square. Any even power will be a perfect square for a variable, or a number for that matter. So let's factor that one. So the square root of 9x to the fourth is 3x squared. So I'm going to put that there and there. The square root of 100 is 10. That's going to go there and there. That's the factoring, that's the correct factoring, 9x to the fourth minus 100. Now, one note you want to make is sometimes you'll have to factor out a greatest common factor in order to be able to factor it even further, or it could be that's the only factor, only way you can factor it, as we saw in the last unit, or the last section. But this one, I think you can see you can do a couple of things here. But let's look at 3x squared minus 27. Neither of those are perfect squares, even though x squared is, but the 3 makes that term not a perfect square. 27 is not a perfect square. But I could recognize that I have a perfect square, I have a common factor of 3 in 3x squared and 27. And when I do that, I get 3 times what equals 3x squared, that's x squared, and 3 times what equals negative 27. That's 9. Now, you'll notice that I can factor this further. This is the difference of two squares. So, just like a number could have 3 factors, let me erase that, get that a little clearer. A polynomial can easily have 3 factors. So it has 2 binomial factors, 2 conjugate binomial factors, and it has a numerical factor. And you always want to factor out the greatest common factor. When I have 100a squared b and 36b, well, this b makes it not a perfect square because it's not to an even power. So I do have a common factor, even though 136 are perfect squares. I do have a common factor in there of 8. So I'm going to factor. I'm sorry, not 8, but 4. I'm going to factor out a common factor of 4, and in both terms have a b. So I'm going to factor out a 4b. And that will leave me with 25a squared minus 9. So I think you can recognize that 25a squared and 9 are perfect squares. So I can factor the difference of two squares inside the parenthesis even further. So I'm going to make that 5a plus 3 and 5a minus 3, and that's all I can do. All right.